Okay, in this video we're going to take an intuitive approach to De Morgan's laws which apply to logical statements and negations. And I want you to realize that you don't need to memorize these laws, but you can think of them in a way that makes sense. So you can always take them with you wherever you go. And the idea is that, and the laws state that if you negate, this is the negation sign, P and Q, what is logically equivalent to this? So in other words, if you take P and Q and you're always taking the opposite of that, is there another way to do that? Well, there is. If you almost think of the distributive property in some senses, you can distribute this sign. So it becomes, instead of P, you have not P. When you distribute to the sign, instead of and, you have or. And instead of Q, you have not Q. And these things are logically equivalent. And the idea is that, well, let's say we have a truth table with P and Q, right? So we can have P be true and Q be true. We can have one true and one false, and the reverse, right? Or we can have them both false. Now, if we have P and Q, what's going to happen? Well, the end statement's only true when both items are true. Otherwise, it's false, right? Okay, so it's only true in the first case. Now, what happens if we negate that? So not P and Q. Okay, so that means we have the opposite. So instead of true, we have false. Instead of false, false, and false, we have true, true, and true. And we're saying here that this is also logically equivalent. So not P or not Q. But let's first find not P and then find not Q. So basically now we're going to reverse these signs. So we have false, false, true, and true. I'm just reversing these 1, 2, 3, 4 there. And the same thing with the Q, we're going to reverse them. So whenever it's true, it becomes false. Whenever it's false, it becomes true. Right? So we have, and sorry, my handwriting's a little sloppy, I realize. We have false, true, false, true. So now we have not P or not Q. Right? That's what we're finding. So if we're correct here, and this is why there's no need to memorize, we should get the exact same thing that we get here, because if they're logically equivalent, they'll give us the same output of false and true. If it's not correct, if we made a mistake somewhere, often students forget, is it or is it and? Which one do we do? I can't remember it. Well, plug it into the table here and see which one works. So here, let's plug this in. So first we have an or statement to deal with, and first we have two false statements. That means when you have an or statement and they're both false, it's still false. If one of them is true, it's true. False, true. True, false is true. And then lastly, true or true is true. So here we get false and then true, 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 which is equivalent to this statement right here. So these two things are equal. That's the first part of De Morgan's law. And the second part follows a similar idea. The second part just says, okay, well, what if we're negating, let's negate P or Q? What's going to happen? As you might predict, a very similar thing will happen here. We negate P and get not P. We negate the or sign and we get and we negate Q and we get not Q. And if we don't believe that this is true, we can set up a truth table to test the validity. So let's do that real quick, because like I said, I really believe there's no need to memorize any of this here. So again, we start with P and Q, although I should do lowercase q, because that's what I'm writing up here. So P could be true, and so could Q. We could have true and false, we could have false and true, or both terms could be false, right? Okay, if that's true, we're trying to test an or statement here, so let's find out P or Q. Well, remember, with an or statement, you only have a false result if both terms are false. So that means we'll have true, 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 and false. Now we're negating that statement, right? We're saying not P or Q. So that would mean, if we follow, of course, the order of operations, we solve parentheses first and then negate that. So that means we'll get the opposite results. We'll get false, 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 and true. So we're trying to determine, is this logically equivalent? Not P and not Q. So what I would do then is list out not P, list out not Q to see what's happening. And this again is just going to reverse all of our truth values in the first two columns. So we get false, false, true, and true, and false, true, false, true. So we can finish this off finally by saying, well, what's the value of not P and not Q? So with an AND statement, again, you only have a true result when both terms are true. So here, right, true and true is true, otherwise we have false results, right? We're looking at these combinations here. So that means we get false, 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 true, which is exactly the same thing that we got with originally. So these two are equal, and this is in fact correct. So we can quickly set up these truth tables to evaluate if we've written De Morgan's laws correctly. Alright, I hope this helped.
Hi guys, so today we're working on truth tables. These can be found in sort of discrete mathematics or logic type problems. So we have our first example here. If P, then the negation of P and Q. So how we start our truth table is by drawing up our columns. So the first one that we've got a P, and we also have a Q. Then we have here a P and a Q. And then we have the negation of P and Q. And then we have the whole example. Oops. There and there. Okay, so how we start it off is by going into the very first column, and nice and easy, you just go true, true, false, false. Head over to the next column and we go true, false, true, false. That way we've got every sort of possible combination. So we've got true, 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 false, false, true, false, false. Then we go into P and Q. So what that is saying is they want true in both the P column and the Q column. So we've got here the P column has got a true, the Q column has got a true, therefore P and Q is true. In the P column here we've got a true, and then we've got a false. So you don't have a true in both columns, so that is a false. Next one, we've got a false and a true. You don't have true in both columns, so that is false. You've got false and false, so you don't have a true in either of the columns, so again that is false. Now we go to the next column over, not P and Q. Anytime you have this negation symbol, it's going to be the exact opposite of what it's in front of, basically. So we've got the P and Q column, not P and Q is going to be the exact opposite of what is here, which is false, true, true, and true. Then we head over to the next column. So we've got if P, then not P and Q. So we've got two different columns here. We've got the not P and Q column, which is this one, and we've got the P column, which is the first one. So we have a look. Now what you do, these two, is you have a look at what the arrow is pointing to. If that is true, then it doesn't matter what the other side says, it's always going to be true here. So we'll have a look, we've got true, true, and true, so we know automatically that those three are going to be true. Now we have a look at this one. We've got a false here and a true here. So if you have a false and then a true, this column is false. If you have a false and a false, then it's going to be true. If you have a true and a true, then it's going to be true. It takes a little bit of getting used to, but once you memorize that, then you'll have no problem with it. So that is our completed truth table for that example. Now we'll head on to another example. I'll just copy it down here. Oops, black pen. P or not Q, if and only if R. So again, we copy down our columns, but this time it's a little bit different in that we've got three different letters, P, Q, and R. So what we want is a P column, a Q column, and an R column. We have a look at what other elements we have in this equation. We've got a not Q, so that's a column that we want. There. And we've also got a P or not Q, so that's another column. And then we've got a P or not Q if and only if R, so the entire equation. Okay, so this time, now that we've got 3 different letters, we want a few more trues and falses in the starting column. So we go true, 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 false, 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 and false. Got to make my columns a little bigger. There we go. Okay. And now, so we've got 4 and 4, so now we want 2 and 2. True, true, false, false, true, true, false, false. Now we head over to the R column. Now we're going to do, we did 4 and 4, 2 and 2, now we're doing 1 and 1. So true, false, true, false, true, false, and true, false. Okay, then we head over to the next column. We've got a not Q. We've already done the Q column, so the not Q column is going to be the exact opposite of this one. So we've got false, false, true, true, false, false, true, true. Heading over to the next column, we've got P or not Q. So if it's P or not Q, we want a true in either the P column or the not Q column. So our P column is here, our not Q column is here. We've got true, false, so that's at least one true. So we've got a true. True, false again, we've got at least one true, so that's a true. True, true, we've got at least one true, so true. Again, the same thing. False, false, don't have any trues, so that is false. False, false again, so don't have any trues, so that's a false. True, false, have at least one true, so that's a true. True, false again, we have at least one true, sorry, so that is a true. Now we go over to the last column. We've got P or not Q if and only if R. So we've got our P and not Q column here, we've got our R column here. So if and only if. What we want from an if and only if is we just want a double true or a double false. If it's anything else, then it's going to be false. So double true, then we've got a true. True and false, that's a false. Double true, that's true. True and false, false. False and true, that is false. Double false, so we've got a double, so that's true. True and true, we've got another double, so that's true. And then true and false, so that is false. So that is the general gist of truth tables. I hope this has been helpful. If it has, give us a big thumbs up. And yeah, I hope that this makes it a little bit clearer and a little bit more easier. Thanks, guys.